Hey guys, hope everyone is doing great. In the previous video, we talked about um, sum of interior angles of polygons. We found out, how many triangles can we make within that polygon based on that. You know, we found out that your number of sides minus 2 triangles is what we make. If it's a 12-sided polygon, then we make 10 triangles, and the sum of interior angles is 10 times 180. That's what we just talked about. Okay, let's bring another perspective here. Let's talk about the polygon types. And we can talk about these polygon types from two different angles or perspectives, right? One is convex polygon and a concave polygon. So in convex polygon, all the internal angles here, every one of them, it can't be more than 180 degrees. It will always be less than 180 degrees. If all the internal angles of a polygon is less than 180, then it is called convex polygon. These are the regular ones, polygons. When we talk about it, 9 out of 10 times we talk about convex polygons. But these concave ones are different. These concave ones will have this little dent here, okay, where this some of these angles are turned inward. So in a pure definition perspective, if we go by the interior angles, look at this interior angle, it's less than 180. Okay, this is fine, less than 180, less than 180, less than 180. But let's take a look at this guy here. Let's take a look at this angle here. This is more than 180 degrees because of the dent, or because of the dent inward, that inward angle, right? So since this polygon has an angle that is more than 180 degrees, this is concave polygon. This is called concave polygon. And that's between convex and concave. Now, I'll bring another perspective, another type of polygons, right? So there is something called regular polygon and irregular polygon. In regular polygon, what happens is all the sides of the polygon are congruent. This is same length as this one and every other side. This is called regular polygon. All the sides are congruent and all the angles are also congruent. They're all same. They're all same. So all the sides of a regular polygon are same. All the angles of a regular polygon are also congruent. And actually, there is a center point here for all the regular polygons, okay? And all these vertices of a regular polygon, they are equidistant from this center. They're all equidistant. Okay, they're all equidistant. And now, what did I say? These are all same. All these sides are congruent, and these angles are congruent. And then these are all equidistant from the center of the regular polygon. Okay. Now that is not the case with irregular. Either they will have a longer side or shorter side. They the sides of all the sides of a polygon are not congruent. See this one? This is longer than this. This is longer than this. And also the angles are also not congruent. This is irregular polygon. Now, this is polygon types, right? Now let me bring another perspective here. Let's talk about the convex polygon. What I'm going to talk about is applicable only for the convex polygons. So let me build one convex polygon here. Okay. I'll take a square. There's no better example than that. So it's also regular. Okay. Or I'll take another pentagon also. Okay. So it doesn't matter whether it's regular or irregular, but these must be convex. Okay, both of them are convex in this case. So the point that I'm going to talk about is about exterior angles. It is about exterior angles. We are done with interior angles. Now we are talking about exterior angles. So what will be the sum of exterior angles of a convex polygon is essentially the topic name. Okay, so how do we get the exterior angle? So I'll take this vertex, and then from this vertex, this is the side, I will extend this side. Okay, so this is one exterior angle, and then I'll take another one, I'll extend this guy. This is another exterior angle. I will extend this guy, and then another exterior angle, and let me extend this side, and then the angle that is formed here, this is called exterior angle. So we have 4 exterior angles. And now I'm going to tell you something interesting here. So let's say you started an object here. Let's say you take a car here. Okay, let's say you started a car. This is a funny car, right? This is what I meant actually. This is what I meant to draw. Okay. So now it's sitting here, and now let's go around that. Let's go around our polygon. So if I go here, this car will turn 90 degrees, and then another 90 degrees, and then another 90 degrees, and then another 90 degrees. It will come back to the original shape. Imagine a same car here. Okay, same vehicle here. Now imagine this vehicle going okay, let me okay, these are all the exterior angles that it formed for this pentagon, right? So now imagine this car is turning here, going into this, going in this direction, and again turning here, going in this direction, turning here, going in this direction, turning here, going in this direction, and then turning here. It will always come back to its original position. When would an object come back to the original position? When it completes 360 degrees. So what I'm trying to say is that sum of exterior angles of, but it has to be a convex polygon. It doesn't work with concave because of the dent or inward angle, right? Sum of exterior angles of a convex polygon is always 360 degrees. And the beauty is irrespective of the number of sides. So that could be a four-sided polygon or five-sided polygon or 100-sided polygon. As long as it is convex, the sum of exterior angles of a convex polygon is always going to be 360 degrees. And in the next video, we'll talk about, we will take a regular polygon, and then in the regular polygons, all the angles are congruent, right? So now we'll take that those two concepts. How can we? What happens in the case of regular polygon? The sum of exterior angles, they're all same. All the angles are same. So this 360 divided by the number of sides, and each one gets so much. We'll talk about all of that in the next video. That will be pretty interesting. Okay. Take care, everybody. That's all for now. Okay. Bye.